The bar starts off in this state, completely raw. If you look, there's no features, so there's nothing on there. And then it moves on to this state. So in this state, we have connections on this end, we have a connection on the other end. It's ready to be put on the machine. This machine takes our raw material and it puts a hypocycloidal file onto bars. You see a spindle bobbing up and down, and it's also rotating quite fast, probably around 590, 600 feet per minute. There's about 30 cutters on there, and each cutter is chipping away at your raw material. The up and down movement of the whole spindle is timed with the rotation of the bar. This, in relation to your spindle bobbing up and down, is timed differently, and that's where it gives you your 5 lobes, your 6 lobes, your 7 lobes. So for every time it rotates 360 degrees, it moves about 2 millimeters to the left. And that's our Z feet per revolution that we use, and it varies for all our models to make sure we don't overwork our cutters. And at the halfway point, we change the cutters and rotate them so they get a fresh new surface to cut with. We have to machine within a plus or minus 4 thou tolerance band. 4 thou is basically the width of a human hair. You can imagine the type of precision that's built into all your movements in the machine. When we inspect it, we want to be within a plus or minus 5 tolerance band. Around 20 inches, we'll mill and we'll say, hey, is our program working? Yes, it's working. Let it rip. We have a slew of models that we make, so every model gets a different profile. The major of this is different than the major of this, so different size. Some have 6, some have 5, some have 8. It depends on what the customer and the application. The milled finish looks like a snakeskin finish. It's basically little divots that the cutters are taking out as they're going in. After we mill the rotor, you have that snakeskin finish. It goes onto our polisher. And this polisher is a custom-built polisher with a company in Austria. A lot of the polishers out in the market, they apply pressure to your profile, but they apply pressure unevenly to your major and to your minor. You see the movement over there, how it's rotating and it's bobbing up and down. This mimics that based on the same program. So we make sure that the entire surface gets even amount of pressure. So you're taking off the same amount of material. You don't take off much material, but you're polishing it evenly all the way across. We've got various sanding belts that we do apply for different surface finishes, whether it's going to be chrome coated or carbide coated, using diamond belts to do our finishing touch. These are all the different types of belts that we use. We may go across the first pass with a rough grit, and then we may finish it off with a high grit. And your whole polishing unit is basically bobbing up and down. So you can see how the sanding belt sort of just follows the profile. And after these get polished, we coat them. You either coat them with chrome or carbide. So you can see the carbide finish. It's been polished and an application of HVOF carbide is on there. And that helps with the longevity. This surface is what interfaces with our rubber. So you want the smoothest surface touching the rubber. So these are all acceptable coatings for us. They're just different service providers take their surface finish to a different level. So you can see this dull finish, still acceptable for us. It's got a nice RA. This is a shinier one, so they've spent a little more time polishing it. And these guys have spent the most time polishing it. That's why it's it's even shinier. All our rotors are going to be at least a 10 RA surface finish. So you can imagine that when this is inside of the stator, it's being compressed up against the rubber. So you want the smoothest surface compressing it, or else you'll get a lot of wear on your stator.